In today's lesson, we're going to be discussing how to find the derivative function using something that is called the power rule. Let's get started. For a nonlinear function, the slope or the gradient of the tangent line changes as you move along the graph, either getting steeper or flatter as you move. The derivative function, which is notationally either f prime of x or dy dx, is going to describe the slope. So it's going to give us the slope of the tangent line, like what we did yesterday in class when we found the instantaneous rate of change. The difference today is, instead of looking at the graph, we're going to be taking the derivative to algebraically find the slope of the tangent line. To find the derivative, we're going to use what we call the power rule. So we're going to start with the original function of y equals a times x to the nth, and for the derivative, again this notation represents the derivative, we get n times a times x to the n minus 1. So what happens is our exponent is going to move to the front, as we see here, and the new exponent is going to be 1 less. Let's go ahead and look at that with our examples here. We have y equals x to the 6th. For the derivative, again the exponent is going to move to the front, and the new exponent is going to become 1 less. So f prime of x is going to then equal 6x to the 5th. For our next example, we have an f of x equals 5 times x to the negative third. Again, the negative 3 is going to come to the front, and the new exponent is going to be 1 less. So we get f prime of x is going to equal negative 3 times 5 times x to the negative 3 minus 1. When we simplify that, we get negative 15 times x to the negative 4. So again, for the power rule, the way we use it is we take the exponent and put it in the front, multiply by any constants that are there, and then the new exponent is going to be 1 less. The power rule can be applied to any number of terms within a polynomial. So if you look at our example here, we have 4 terms. I'm going to treat each one individually. Before we do it though, we want to note that for the negative 5x term, the exponent is 1. And then for for the 3, it can be written as 3 times x to the 0 power. So when we use our power rule, again the exponent comes to the front, giving us 3 times 2 x to the 2nd, plus 3 times 2x to the 1st, minus 1 times 5 x to the 1 minus 1, and then plus 0 times 3x to the 0 minus 1. Our first term is straightforward. We get 6x squared, and then we have plus 6x. And now I want to point out something here. When you had a single x initially, or x to the first power, for the derivative, the x just goes away, and we're going to get just minus 5. And then when we had no x at all, notice that we put a 0 in front, so the last term becomes a 0. And so what that means is, anytime you have a term with a single x, again the x just goes away. Anytime you have a term without an x, a constant, it will go away when you're taking your derivative. Let's try this with another example. Okay, here's our next polynomial. Again, we're going to apply the power rule, which means our exponent moves to the front, and our new exponent is going to be 1 less. So for our derivative, f prime of x, we're going to get 6 times x to the 5th, plus 8 times x minus 3. And that's our answer. Alright, now it's your turn. I want you guys to go ahead and write down what you think the derivative to this polynomial is. With our fractions, we need to treat them as polynomials, or actually rewrite them as polynomials before we can apply our power rule. So I need to simplify what I have here. If I simplify using my exponent properties, since the bases are the same, I can just subtract the exponents. So I get x to the 3 minus 2 over 3, and I can rewrite that as 1/3 times x. When I go to take the derivative of that now, f prime of x is going to be just 1/3. Here's another example of an expression that we have to rewrite. So when I rewrite this, I'm going to break it up into 2 separate terms. We have x cubed over 3x squared, and then negative 4x over 3x squared. Again, we have to simplify both of these. So when I simplify the first term, we're going to get x over 3. When I simplify the second term, I'm going to get 4/3 times x to the negative first power. I now need to go ahead and apply my power rule. We did that for the first term already. So the derivative then is going to be 1/3. And then for next term, it's minus a negative 1 times 4/3 to the negative second, which makes that plus. So whole derivative then is 1/3 plus 4/3 x to the negative second. Alright, we're going to try this one more time here. So again, we can't take the derivative of a fraction. We have to rewrite it first. In order to do that, we're going to set this up in 3 separate terms. So x negative third over 3x squared, and then 4x squared over 3x squared, and finally 5 over 3x squared. So let's go and look at that up here. Okay, now that we have our expression rewritten, we can simplify it. Again, using property of exponents, when the bases are the same, we can subtract them. So for my first term, I'm going to get x to the negative fifth over 3 plus 4/3 plus 5/3 times x to the negative second. Now I can apply the derivative. And again, for my derivative, I'm going to move the exponent in front and make the new exponent 1 less. So when I do that, I get negative 5 over 3 times x to the negative 6 plus 0, because that has no x value. And then we have minus 10 over 3 x to the negative third. Alright, now the whole reason why we want to be able to find the derivative is because by plugging in a value, we can then get the slope of our tangent line, which means we don't have to do it using the graph anymore. So to begin with, we're going to take our derivative for our function here, and we get f prime of x is equal to 6x plus 5. Now that I have my derivative, I can then take the x value and plug it into that derivative function to tell me what the gradient or the slope of the tangent line is going to be at x equals 2. So we have f prime of 2 is then going to equal 6 times 2 plus 5, which is 17. So what that means is, again, the slope of the gradient of the tangent line at x equals 2 is 17, which is the instantaneous rate of change at that moment. Okay, just to make sure that we're comfortable with the notation here, we want to find f prime of 5. Again, that implies we're using the derivative. My derivative, again, from the last example was 6x plus 5. F prime of 5 means that I want to plug that 5 in for x. And then simplify, giving me 35. So again, 35 is the instantaneous rate of change, or the slope of the tangent line for a graph when x equals 5. Okay, that's it for our notes today. Tomorrow in class, we'll be applying the concept of finding the derivative. See you in class tomorrow.